Hello there, fellow math enthusiasts. Mrs. Elzadi here. Today we're taking a look at Unit 8, Notes Day 9. We're going to be focusing on kites. So a kite is a quadrilateral with two distinct pairs of congruent consecutive sides. And just like all of our other shapes, we've got some properties to go along with them. So first of all, since we are dealing with congruent consecutive sides, that means that these two sides, they are equal to each other. And these two sides, they are equal to each other as well. All right, now one of our properties, it says exactly one pair of opposite angles are congruent to each other. All right, it's the angles that are on the shorter diagonal. Now I want you to take a look at this top triangle here. Do you see how that top triangle is an isosceles triangle? Which would mean that the base angles, they have to be equal to each other. And then if we go ahead and we look at this bottom triangle, it's also an isosceles triangle, which would mean that its base angles would have to be equal to each other. So if we add up two sets of congruent angles, then their sum also has to be congruent as well. So that's why those two angles there are congruent to each other. The next one says that one diagonal is the perpendicular bisector of the other. The longer diagonal bisects the shorter one. So I'm going to see that I've got some right angles in the center here, and that these two pieces, they are equal to each other. And then the last property tells us that the longer diagonal bisects a pair of opposite angles, which means that these top two little angles are equal, and it means that these bottom two little angles are equal as well. All right, now if you take a look, I want you to see here. Notice that these two angles are equal, that these two angles were equal, that these two angles were equal, and that these two angles were equal. Do you see how it is symmetrical along that longer diagonal? Okay, that's always going to happen with a kite there, just so we know. Okay, so as we move from the top to the middle to the middle to the bottom, those pieces, they are equal to each other. So let's go ahead, let's try and deal with some of those angles in this problem here. It tells us SCAR is a kite, and it says SA is the short diagonal. Tells us the measure of SRA is 46. So SRA, that's this big one here, is 46 degrees. I'm going to put it on the outside because I'm going to put only the little ones on the inside of our kite here. It also tells us CSA is 35. So CSA is 35. And I want to be able to find all of these angles. I'm not even going to look over to the side right now. I'm going to focus on finding everything in my kite first. I do know that the diagonals are perpendicular to each other. So I'm going to put my right angles in. And I do again remember that this is an isosceles triangle. So if it's 35 here, it has to be 35 here as well. And then there is 180 degrees in a triangle. So if I do 180 minus 90 minus 35, I'm going to get that this angle up here is 55. And then if it's 55 on the left, it's also 55 on the right. And then I'm going to move down here to this 46. 46 gets split in half. So I have 23 and 23. And then again, if there's 180 degrees in a triangle, 180 minus 90 minus 23 gives me 67 on the left and 67 on the right. Now take a look again. The 55s, they match. The 35s, they match. The 67s match, and so do the 23s, okay? It is symmetrical along that long diagonal. Now let's take a look here. I want the measure of SFR Well, that's 90 degrees. I want the measure of ARF. Well, that's 23 degrees. Of SCR, that's 55 degrees. Of SCA, well, I've got to add those two together to get 110 degrees. And then of ACF, that is 55 degrees. We've just found all of our angle measures in our kite. Let's go ahead, let's flip it over now, and let's deal with our side lengths. So I'm telling you GLOV again is a kite with LV being the short diagonal. I want to find GOLV and then P of GLOV. That means I'm looking for the perimeter. So first of all, I want to put in the fact that these guys here, those are right angles, which means I'm dealing with right triangles. Right triangles, think Pythagorean theorem. It's going to come into play a whole bunch when we're dealing with the sides of our kite. Now, it does say that LV is the short diagonal. The short diagonal gets bisected. So if it's 12 on the bottom, that means it's 12 on the top here as well. LO is 20, which means that VO is also 20. Now, I want to go ahead, I want to focus on this right triangle on the left-hand side here. I'm going to call this piece X. I see that X is the hypotenuse of that triangle. So I can say X squared is equal to 5 squared plus 12 squared. That's X squared is equal to 25 and 144, which is 169. And if I take the square root, I've got X to be equal to 13. If it's 13 for GL, it is also 13 for GV. Now I also need to go ahead and take a look at this triangle. I am missing this piece right here, which I'm going to call Y, and I'll say 20 squared is equal to Y squared plus 12 squared. That's 400 is equal to Y squared plus 144. And if I move that 144 on over, well, that's 256 is equal to Y squared, which will make Y equal to 16. Now, I wanted to find what GO was. GO, well, 5 plus 16 gives me 21. I wanted LV. 12 and 12 give me 24. And then I want the perimeter. So if I do 2 times 13 plus 2 times 20, that is 40 and 26, which will give me the perimeter to be equal to 66. So those are the main two types of problems that we're going to see with kites. I've got some more time in this video, so I'm going to go ahead. I'm just going to go through again how we go about dealing with those angles. It tells us, first of all, that we have a kite and that FO is the short diagonal. So that means I've got right angles working all around here. Angle FSO is 66 degrees. Angle ROF is 41 degrees. Keep in mind again, it is symmetrical over that long diagonal. So if it's 41 on the right, it's 41 on the left. We have 180 degrees in a triangle, so 180 minus 90 minus 41 gives me 49 on the right and 49 on the left. If I take a look at my 66, I have to break that in half to get 33 and 33. And then 180 minus 90 minus 33 gives me 57 and 57. Now that I have everything filled in, I can go ahead, I can find my missing angles. ROS, I need to add the 41 and the 57 together. I'll get 98. STF is going to be 90. RFT I see is 41. TFG SF I see is 33. And ORF, when I add that together, is 98. And I'm going to put my degree bubbles for all of those. All right, looking at number 4, SNOW is a kite, NW is the short diagonal, which means I've got my right angles and these two pieces are equal. If it's 8 on the bottom here, it's also 8 at the top. If NO is 17, then WO is 17. And now I'm going to focus on this top triangle. I'm missing the side length, which I'll call X. That's x squared is equal to 6 squared plus 8 squared, making x squared equal to 36 and 64, which is 100. And when we take the square root, we've got x to be equal to 10. So if SN is 10, SW is also 10. And now we'll go ahead, we'll focus on this triangle on the right-hand side. I'm going to call this piece here Y. We'll say 17 squared is equal to 8 squared plus y squared. That is 289 is equal to 64 plus y squared. I'll move that 64 on over. That is 225 is equal to y squared. Take the square root, making y equal to 15. Now things that I was looking for SO. Well, from S to O, 6 and 15 will give me 21. I was looking for NW. 8 and 8 will give me 16. And then if I want the perimeter, well, that was 2 10s and 2 17s, so 34 and 20. I'll have that the perimeter is equal to 54. All right, one thing I want you to keep in mind too is what my little snowman is saying here in his bubble, is that when you're using the Pythagorean theorem, you might not always get a nice, pretty number. Sometimes you're going to get a nasty decimal. That's okay, we'll round that decimal to 1 decimal place, the nearest tenth. So we've talked about our kite. Our kite has 2 distinct pairs of consecutive congruent sides. The diagonals are perpendicular to each other. One set of opposite angles are congruent and one set of opposite angles are bisected. Del Zadi is done for today. I will see you in class.